In my last video, I talked about why 0 times infinity is not 0, but I realized that I never really talked about what a number even is. I know this because many of you were confused in the comments. Now, conventionally and in programming, when people talk about numbers, they're usually either talking about the set of real numbers or complex numbers. But what even is a real number? That's what I'm here to teach you guys today. And don't worry, I'll be including plenty of sound effects and vine booms to keep your small attention spans. Oh, and small disclaimer, if you're an expert in number theory or real analysis, this video is not for you. Instead, just go watch my video about being pedantic. Alright, let's get started. Now, to put it simply, the real numbers are just a set of all numbers on the number line. But how did we get the number line? Well, we have the symbols for the numbers, but then we made up a bunch of rules and operations. These are the basic rules and symbols. These symbols just define our numbers, and we also have operations which can take two numbers and give a third number. In addition to these, we also have some basic properties called axioms. Axioms are just things that we define as true. Now, broadly speaking, the set of real numbers satisfies three groups of axioms: the field axioms, the order axioms, and the completeness axiom. Now, it might seem like I'm talking about something totally unrelated, but please just stick with me. I'm going to first briefly go through the field axioms. The first two I'm showing on screen are super simple. You probably don't even think about them.
Bruh.
The next one's a mouthful, but all it really means is that there's a 0 and a 1. And the most important one is that every number has a corresponding negative number and a corresponding reciprocal except 0. Now, a lot of these rules might sound super simple or obvious. And that's because we teach math in a way where you kind of just assume a lot of these things to be true. Now, when you take a number that's not real and you try to shove it into this rule set, that's when things start to fall apart. My main example for something that's not a number is going to be infinities and infinitesimals. And this is where you start to see the rules kind of fall apart a bit. For example, let's look at the multiplicative inverse rule. Does 1 over infinity have a multiplicative inverse? Or is there a number x such that 1 over infinity times x equals 1? You might think it's infinity, but not really. If you use Wolfram Alpha, you'll actually see that the answer is not true. Now, the astute among you might ask, well, why can't we just define infinity to follow the axioms? And that's a good question, but we'll need some more axioms to answer it. So let's move on to the order axioms. To keep things simple, let's define A, B, and C to be real numbers greater than 0. If A is less than B, then A plus C is less than B plus C. If A is less than B, then AC is less than BC. And for any A and B, either A is greater than B, A is less than B, or A equals B. Without these axioms, the numbers don't actually have to be in a line. They can sort of just be in any order. These axioms to construct an order that all the real numbers follow. This is also important because it lets you sort of mathematically get to any single number. For example, I could go from 1000 to 1 by doing a bunch of additions or multiplication. But something like infinity, you can't quite get to in the same way. So those axioms we've talked about so far really get you almost all the way to the number line, in that they give you the numbers and then they tell you the ordering. But there's one step missing, and that's the completeness axiom. Now, I spent a lot of time trying and failing to come up with a good explanation of this axiom. Now, it's not super rigorous, but I have come up with a good way to phrase the axiom. Every number has a number directly after it. Sounds super obvious, right? Well, let me ask you this. What real number comes directly after 4? Is it 5? Nope, there's 4.1. But there's also 4.01, and 4.001, and 4.0001. I can't tell you what number is directly after 4, so that's why we need the axiom. It states that even if I can't tell you what number comes after 4, it does exist and it is real, just like Santa Claus. This axiom is what makes it so that there are no gaps in the number line. If I pick a random point on the number line, it's gonna be a number. And with that out of the way, you now know all the axioms of what makes a number. Alright, that was a lot. So to recap, a number is only real if it follows the field, order, and completeness axioms. If we try to add a number to the set of reals and it breaks any of the axioms, we say that number is not real. There are ways to change the axioms a bit to make infinities work, like in the hyperreal numbers. And if you are interested in those, please check out this video. I thought it was very good. But yeah, that's all for the video. Thanks so much for watching. If you liked the video, make sure to hit like and subscribe, and make sure to let me know in the comments if you learned something new. I definitely learned a lot while making this video, so I hope you guys did too. Have a great rest of your day, and I'll see you guys in the next one.